So these are extra examples. We're just adding these to our notes. So let's say we have x minus 4 over 9x minus 18 minus 6x over 3x. Okay. So anytime we have a denominator that has multiple pieces, like this is a binomial, this is a monomial. Anytime we have a denominator that's got multiple pieces, what do we have to do to kind of like break it down? You can look back at your other notes. Starts with an F. We have to factor it. Okay. And how do you factor this denominator? GCF. What's the GCF? 9. So we have 9 times what? X minus 2. Okay. And then since this factor on the bottom, since this denominator is going to be compared to a monomial, it could be helpful to take this GCF right here and think of the factors that made 9. So what are the factors that make 9? How do you break down 9? It's a 3 and a 3. So I'm going to think of this as a 3 and a 3 multiplied together and an x minus 2. That's going to be the easiest way to think of that denominator of all like the different pieces that made that denominator. Okay, and then if I think of this denominator over here, it's 3x, and what are the pieces that made 3x? 3 times x. Okay, so if we are going to come up with a common denominator, how many pieces do we need? What are the different things we have? How many 3s do we need? Well, we've got 3 total, but what's the most that we need in one fraction? 2 for one fraction is the most that we have. So we need to have 2, because this one had 2, but this one only had 1, and so 2 wins. Okay? So we need to have 2 3s. What else do we need to have? We need to have an x, because that had an x that was plain. What else do we need to have? An x minus 2. Okay, so our common denominator needs to have 3, 3, x, and x minus 2. And if we clean that up a bit, 3 times 3 times x is what? 9x times x minus 2. Okay, there's our common denominator right there. Okay, so if I think about this, I have an x minus 4 on top, okay? Now on the bottom, I have 3, 3, and x minus 2, and I'm going to compare this with what my common denominator should be. I have a 3, 3, and an x minus 2, so what does it need? It needs an x, okay? So that means, everyone see that? We're good? Okay, so that means I'm going to take what I had in my common denominator, or for the denominator that I already had, and I'm going to go ahead and put parentheses around this, and I'm just going to put an x on the top and on the bottom. So whatever I do to the top, or whatever I do to the bottom, really, the common denominator is 2 3s, an x, and an x minus 2. And we had 2 3s, and we had an x minus 2, but we didn't have the x. And so we had to put an x on the bottom to make the common denominator. And if we put an x on the bottom, we have to put an x on the top. Okay. Now, the other one, we have 6x over 3x. Okay, so if we look at this, we have a 3, we have an x, and then what are we missing? A 3 and an x minus 2. So I'm going to have to multiply by a 3 and an x minus 2. And if I do it on the bottom, I have to do it on the top. Okay. So for my first fraction, I have what on the top?
X to the second minus 4.
X to the second minus 4x. And I'm going to leave the bottom in factored form. Is everyone okay with that?
Yeah.
No. Well, yeah.
Yeah. Okay. And then,
You don't have to do that. You don't have to break it down. Swear.
okay. And then over here, I have 6 times x times 3.
18x.
Okay, so this is 18x, and that's going to multiply by x minus 2. And so what do I get? 18x squared minus... Wait, what's 18x times 2? 36x. Okay. So 9x, x minus 2. Now, I believe in the video, this is where it kind of stopped.
Yeah.
Okay. So now, but we know from yesterday, we can keep going, right? We have a common denominator.
So we're going to solve it now.
So now we're going to keep going. Okay. So our common denominator is 9x times x minus 2. I'm just going to leave that common denominator. I have x squared minus 4x. These problems aren't necessarily the most difficult that you've ever seen. We're just getting to the point where we have to be really careful. That's all that's happening, is we got to be really careful. Okay, minus 18x squared. Yes, it is. Minus 18x squared plus 36x. And I apologize. I know you guys are so used to things like working out nicely and canceling out, but I was not able to do that for these examples. I did that on the worksheet for today. I came up with problems where things would, like you'd factor and things would cancel nicely, but I did not do that for these 2 example problems. I got tired of coming up with things that would cancel. So if we combine like terms, what do we get?
When we get
Okay.
16x in the second plus 32.
Plus 32x. Okay. And we don't have much factoring that can be done, but we do have a little bit. What factoring can be done? We can take out an x, and if we have a negative in the front, what do we usually do? Take out the negative. Taking out the negative in this particular problem won't help you, but we're going to do it anyway, just to form good habits. So I'm going to take out the negative, I'm going to take out the x, and what does that leave me with?
Negative, 17x plus 32. No, minus 32.
Good correction, okay. And then on the bottom, we have 9x, x minus 2. And is there any reducing that can be done without killing puppies? Yes. Because we have changed this to a multiplication problem, so now we can reduce a little bit. We can't touch the parentheses, right? But we can reduce the GCFs. The x's and the GCFs are okay.
17x minus 32.
Over 9x minus 2. It's not pretty, but that's the answer. Yeah, your answers on your practice worksheet are going to be a little bit prettier because I manipulated them to be prettier. Okay. Yeah, they're going to be prettier. Yeah. It was just when it came to coming up with examples on here, my brain was like fried because I had been coming up with a bunch of problems and I was like, nah, I'm done. I'm done coming up with problems. Okay, let's do one more example on here and then let's switch over to our worksheet. Okay, p minus 3 over 15p squared plus 3p minus 2 over 2p So
Gotta figure out this.
look at this denominator. What can we do with it?
We can factor out of 3 GCF.
Okay, GCF of 3p, and what's left over?
5p plus.
Okay. So in the front, I'm just going to think of this as like a 3 times a p, and then a parenthesis 5p plus 1. This denominator over here, if we think of the factors that made the 2p, it's just a 2 and a p. And so for our common denominator, what plain numbers do we need?
3.
A 3 and a 2. Just a 3 all by itself, a 2 all by itself. What about variables that are all by themselves? Yeah, just one p. Yep, because they each only have 1. So we just need 1 p, okay? And then we need just one of the parentheses, 5p plus 1. Okay? And if we put that all together, what is this?
6p times 5p.
Okay, 6p times 5p plus 1. Okay. All right, so I'm going to start writing down the first fraction. So it's currently 3p times 5p plus 1. So all I've done is written down the first fraction. The first fraction has a 3, has a p, has a 5p plus 1. So I'm going to cover that stuff up. It has a 3, has a p, has a 5p plus 1. So what does it need? It needs a 2. Needs a 2. Okay. So I'm going to multiply by 2 on the top and on the bottom. Okay. All right, the other fraction has a 2, has a p. What does it need? A 3 and a 5p plus 1. Needs a 3 and it needs a 5p plus 1. So needs a 3, needs a 5p plus 1. So we're going to do that on the top and the bottom. Okay. So this might be a day, this probably is a day where my worksheet won't give you enough paper to use, won't give you enough space, and you might have to use a separate sheet. Okay. So for the first fraction, what do we have on top?
2p minus 6.
Okay. And my denominator is 6p.
And then 5.
Okay. And then for my second fraction, I've got 6.
So 30p plus 6.
30p plus 6. Okay.
30p.
So I'm going to go ahead and write my common denominator. I'm going to copy this down on the top, the 2p minus 6. And then I'm going to make sure that I'm subtracting each of my other terms. You just add.
Add it.
Yeah.
You don't like doing switching the sign.
Yeah. Mm-hmm.
We can still set it up like that, just like that, but instead of switching the signs, we get it over there, and just put it normally. And then
Yeah, a lot of students don't even do this part because they just have to combine like terms with adding, so it saves you a step, which is why I don't teach that first, because then students will always save themselves that step, and then they get half the problems wrong.
Negative 28 minus 12.
Okay, so if we combine like terms in the numerator, we have negative 28p minus 12.
Number 5 is 6.
Yeah, negative 4 is the GCF.
Yeah.
Okay.
So then negative on the outside 7 plus 3 and then well 7p plus 3.
7p plus 3. Okay.
6. Wait, is there?
So we can't reduce the parentheses because they're not identical, so they both have to stay there. But these, the GCFs in the front, can both divide by 2. Is this, how far do you want me to go up? Is this good?
Did we take out a negative 2 or a positive?
Just 2, just regular 2, yeah. If you took out a negative 2, it wouldn't be wrong. It would just move a negative to the bottom. And most people don't do that. Most people leave the negative on the top. Yeah, these answers aren't very pretty, but like this. Okay. All right. Which one should we do? Should we do number 1? Number 9. Let's do number 9. All right. All right. How do we start?
We take out 3x.
Okay, there's a GCF of 3x. And once you take out the GCF, the leftovers are x plus 4. Okay. So we have a 3 times an x plus 4. And then over here, we just have a 3 times x. This problem is off to a very nice start. Okay. So what does our common denominator need? Needs a plane 3 because they both have a 3. It needs an x because they both have a plane x. Needs an x plus 4. Okay, so the common denominator is really just 3x times x plus 4. It's pretty simple. Okay, so that means if we look at the first fraction and we look at the denominator, does the first fraction need anything? No, it does not. Okay, so for the first fraction, I'm just going to copy it down. The first fraction does not need anything. Okay? The second fraction has a 3x. Does the second fraction need anything? It needs an x plus 4. Okay, so I'm going to write the second fraction down. 6 over 3x, and then I'm going to write what it needs, which is an x plus 4. I'm going to put that on the top, and I'm going to put that on the bottom. So 6x plus 24.
And are we just counting the common denominator, or are we solving the whole thing?
We are going all the way through. We're going all the way with them. All right. So then we need to write this as one fraction. 3x, x plus 4. I'm going to copy down the first part, x plus 4. I'm going to distribute my negative. So minus 6x minus 24.
Negative 5x minus 20.
You go to negative 5.
Okay. Take out a... We've got a lot of chatting now. So GCF of negative 5. And when you take out the GCF of negative 5, what are you left with? X plus 4. Okay. And what letter does this match up with? L. Letter L. So number 9 is letter L. Okay. Is there another one?
This is easiest for
Should we do another one?
Number 4 it has two.
Number 2 looks pretty.
Okay, number 4. Okay, let's look at number 4. Okay. So 2x squared would be 2 times x times x. 2x squared y would be what?
The same thing but times a y.
Okay. So for the common denominator, what do we need?
2 times x times y.
Okay. So 2x squared y. So each of them needed 1, 2. They each needed 2 x's. And this one has a y, so they're each going to need a y. Okay. So the first fraction has 2 times x times x. The first fraction has 2 times x times x. What does it need? A y. So we're going to say it is 2x squared, and we're multiplying it on the top and the bottom by y.
That's going to be 6y squared.
And does the second fraction need anything? No. Okay. So what does the first fraction have now? 6y squared.
Minus y.
Okay. And then I'm just going to cut off a step on this one, and then we've got minus 9y. Okay. Six y to the second minus 10y. So
You can take out a 2 out of everything.
So we could take out a GCF of 2 up here. What else could we take out?
2y.
2y. Okay, so on the top, we're going to take out a GCF of 2y. And that would leave you with 3y minus 5. Okay. So the parentheses can't go away because those parentheses are not mirrored anywhere else. That's the only set of parentheses exactly like that. Can we take out the 2? Does it cancel? Yep. So the 2's cancel. And the y's cancel. Okay? So your final answer is
3y minus 5 all over the place.
okay, and what letter is that?
It's S.
S?
So number 4 would be S.
All right.